Good evening, friends. So today we are going to understand the fraud analytics with respect to neural network. So we are done with few classification problem. So we have seen clustering problem, clustering mechanism. We have seen regression algorithm, and we have seen some of the classification problem. So in the previous session, we have seen the decision tree. And today we are going to learn about how neural network is helping for fraud analytics. So even neural network can use some of the classification machine learning algorithm, and also it has creation of network that will learn with several epochs, iterations, and then learn from that, and it will give you the result. So today we'll learn about the neural network, which is going to help us in fraud detection. So we'll try to understand that. So network. So this is used as a classifier. As I told you that some of the classification of traditional machine learning model are used for fraud detection. However, the neural network also plays an important role and acts as a classifier in fraud detection. When I say classifier, it will be having a binary classification where it will be having a two things, that is the transaction is fine, okay, or legal, and the transaction is fraudulent. So two things are there, hence we tell that as a classifier. So not only a linear models, a linear data, it also fit for the non-linear data. And it solves more complex tasks when compared to the other classifiers. So we're not discussing that, we just exactly discuss about neural network. So this diagram gives you an idea how neural network is designed. It's been created with input layer. So this is the input layer. And this is the hidden layer. And this is the output layer. So whatever the connection that you have, these connections are referred to be as weights. These connections are referred to be as weights, and you will be having a bias connection for all the neurons. And this is all also a weights. Now what is the importance of these weights? So these weights are helping us to learn to predict the output. So whenever I say there is some small changes on your skin, when there is a small changes on your skin, you feel that. Can you show that field? So we can't show that field. That means it can be the hotness, the coldness, or any field. So when there is a hot vessel hitting on your skin, you'll try to remove that place or remove the hand from there. So that means the information has been passed from skin to brain and telling that what is the intensity of the hotness, that what is the temperature, what is the hotness that you felt has been traversed, and it will inform the brain. So the brain already learned saying that whenever you get a hot to the skin or any part of the body, you just remove the hand. So this is a output that will be from the brain, and the action will be performed by the person. So this is what the neural network also works, saying that the skin is the input layer, and you will be having a hidden neurons, so nervous system. Okay, so this will be your brain. So the skin will have a input saying that hot vessel, and you'll be connected with the nerves, and this nerves will carry the information and tell about the brain saying that this is a hotness and it has been touched to the skin, and immediately the brain will predict an output saying that, and it will tell to person to remove the hand. So the output will be remove the hand. So we'll create a input layer, and we'll have a number of neurons in the hidden layer, and this is a output layer where you will be having a prediction, and you will be also having a actual value in your data set. Let's say example, this is a column where you will be having a output saying yes or no. So you need to get the probability of chances when it is yes, when it is no, when it is yes, when it is no, when it is yes, when it is no. If you are getting here no, then there is a difference. This is a prediction and this is a actual one. When the prediction and the actual one is different, you again need to train your model. So how do you train your model? You go back and then update the weights. Okay. So when you traverse from input to the output, that is referred to be as forward propagation. When you are going and saying that you need to update that this prediction is not actual, it is not actual. Hence, we'll go back and update the weights. These weights are randomly assigned. And with the help of mathematical derivative formula using chain rule. Using chain rule. So what is chain rule? We'll say derivative with respect to loss with respect to W. Whenever we have a difference in the prediction and actual, we'll get that as an error, or we call that as a loss. So the loss function is going to have a change in the weight. So when you are doing with this derivative, why we are doing derivative? Because when there is a weight of this, let's say example, we have a weight 0.08 and you are getting y as an output, that is prediction. So we represent y prediction as y cap. When you have a weight, you are predicting this. Now, if I change the value of the weight 0.06, what will be your prediction? What will be your prediction? So this is referred to be as rate of change, what we call it as derivative. So whenever you are going backwards, let's say example, this is output 1 and this is output 2. So here hidden layer 1, hidden layer 2, hidden layer 3. So this is hidden layer output 1, the hidden layer output 2 and hidden layer output 3. And these are the weights W1, W2, W3. Like this, you will be having n number of weights connected to the input and hidden layer. Now, how this chain rule will work? Let's say example O1. O1 is dependent on the output HO1 and the weight. Okay, so the O1, what you got, is dependent on HO1 and weight. So here when you are doing with respect to the hidden layer, in the hidden layer, you will be having a summation of, this is x, x1 and this is w1. You'll be having x1, w1. This is connected and you'll be having w2 and you'll be having w3 and you'll be having w4. So summation of the input with the weights w3, x4, w4. So we have this formula near the h output 1. This is not an actual value because you need to apply again the activation function. Okay. So here several things are there. First you need to summation and then you need to apply activation function. So the summation is x1 w1, x2 w2, x3 w3, x4 w4. This is the input. Let's become age, occupation, card holder, the number of large purchase on the card, the frequency of the large purchase, the location where large purchase took. So these are some of the inputs given to the network. So network need to understand whenever there is a large purchase, where is that large purchase done. So everything will be combined with summation with the input with the weights, and these weights will be calculated with the help of the formula. So W nu is equal to WO minus loss with respect to WO. So I'll just tell you why W nu and WO. So this is learning rate. So here when you do perform with summation, you'll be getting an output, and here HO1 with respect to W, let's say example W5, you'll be getting output O5, O1. Okay, this is O1 and this is O2. Now when you are going back, O1 is dependent on the weight, or it is dependent on HO1 as well as W5. So I need to change the W5 with respect to the output. So the rate of change of O1 with respect to W5. So this we need to calculate. So this we need to calculate. For this, we'll apply chain rule and get the value. So once you update the weights, the HO1, which is dependent on again W1, is again updated. Let's say example, HO1 is dependent on W1. It is also dependent on W2. It is also dependent on W3. It is also dependent on W4. So like this, it will be dependent on all the weights. So we need to check what is the rate of change of that particular output with respect to change in W1, 2, 3, 4. So why we are changing the weights when you don't get the proper output, saying that it is transaction okay and it is fraudulent. If you are not getting proper output, so actual minus prediction, you'll be getting some error or the loss. So in neural network, we'll always calculate the minimum loss function. So minimum loss function. This is a loss function and this is a weight. So when you increase the weight, you need to have a decrease in the loss. So you can see that this is, we call it as global minima. You can see that the point is here. For the given weight, the loss is here. You can see that the loss is here. Now, if I want to reduce the loss, I need to increase the weight. So I need to increase the weight so that it will jump towards and then come back to the global minima. That means global minima means the loss should get reduced. That's it. So when you increase the number of weights at some portion, the weight, the loss will get reduced and it will become minimum. And even again, when you increase the weight, this portion of the point will again start increasing. So when you see that there is some portion where it started increasing again, there you can stop it. So that position, that means that the model has been trained or it has been learned. So we need to always have a loss function minimum, and that we call it as global minima. So we calculate that rate of change of weight. The rate here, you can see that from this graph, obviously, how much rate I can change the weight so that I can reduce the loss as early as possible. So when I increase 1 unit, when I increase 2 unit, when I increase 3 unit, when I increase 4 unit, because the weight value is randomly assigned, randomly assumed. So I need to always check the rate of change, derivative. We need to calculate derivative. So here derivative plays an important role. So now you got to know that how neural network works. And this we call it as back propagation algorithm. So everything is back propagation algorithm where you need to update the weights. When you are going back and updating the weights, you will be having the formula which I have written. So this is a formula. So weight nu is calculated with respect to the older weight minus this is the learning rate, and it should be very minimum. So researchers has given that we need to keep running rate as 0.001, and you need to calculate the loss with respect to weight. So using this function, we can calculate the weight. And you can see that this should be always minimum. Why? Because when you have a maximum number of learning rate, so since it is multiplication with respect to the rate of change with respect to loss, it is going to have having high. So the value which is going to have high should not be higher than W naught. So see to that the learning rate is balanced so that it is not changed or it is not kept constant. Sometimes we don't keep the learning rate constant because we need to have the rate of change should be happen at some speed. So this learning rate should be sometimes keep on changing or it is kept constant. So we have two things, when we change it or when we kept constant. So you'll find the new weight and again you forward it and then find the actual value. If it is almost nearer to actual value, like how I have showed you, so it will decrease, it starts decreasing and it becomes global minimum. So this is an error graph that you will be writing. So loss and with respect to weight. So only two things that is required for neural network, and then you'll be updated. So whenever you go back and update, then that will be your iteration. You forward it, coming from input to the output, and again you go back. While going back, you'll update the weights. So this is referred to be as one iteration. So we have one more word, that is epoch. So epoch is nothing but, let's say, assume that we have a data set. We have a data set from 1 to 100 observations. So all the observations are passed on to the network and it has been passed through the network at least once. So that is forward, pass through the network. Complete 100 observations are passed through the network and then come back. Then it is referred to be as epoch. So like this, if you make several epochs, so if you make several epochs, then the particular model will get trained and it will check for the actual and prediction value. The simple example that a child is going to be in an empty mind when it is 6 months or 10 months. We'll show a dog or cat, which is a pet animals, and we'll make sure that the child is understanding what is dog and what is cat. By looking to their features, by analyzing the looks, the features, and the sound that they make, so the child is going to learn from that. So whenever the child is in the new place, and the child is tested showing the dog picture, we already know that it is a dog, that is actual, and now the child is going to predict. Now the child is going to predict that it is a dog. If it is predicting cat, if it is predicting cat, then this is wrong. So again, I need to train the child saying that no, it is not cat, it is dog because of several features. Okay, like the same, we need to go back and then update the weights and then make the loss reduce. Indirectly, when I reduce the loss, the actual is almost equal to prediction. So what I want is prediction. What is actual? I compared and it is true. So this is what we are supposed to do with respect to using neural network. So hope you are able to follow me. Hope you are able to understand. Hence, the neural network also understands and supports for classification, and it is also helping binary as well as multi-classification. See, when you are coming forward, there is nothing, right? Only calculations and you are getting output. So when you are going back, there should be someone to update your weights. So in Python, we call them as optimizers. In Python, we have optimizers that is going back and will update the weights, and optimizers is going to take care of that. So we have stochastic gradient descent, mini batch gradient descent, and we have gradient descent. Okay, so these are considered to be optimizers that is going to have updates with the weights. So stock gradient descent is rate of change that is going to perform what I've told you, coming forward, going backward, and using chain rule. It is getting updated with the derivative, and that is all about with respect to make changes with the learning rate. We also have stochastic gradient descent with momentum. So I've told you that we need to reduce the loss with respect to change in weight. So you can see that initially you will be having like this. You'll be having a drop of this point, that is from here. It reaches the global minima. We call it as global minima with this zigzag way. And it is, when it is zigzag way, it is time consuming. So we need to make the path very smoother, so that it will be reaching you the global minima within no time. With no time. So this will help us to update the weights every time. So when you are smoothing, you are updating the weights as well. So optimizer's responsibility is updating the weights, and the weights updated with respect to some rate of change. So that stochastic rate of change gradient descent means decreasing. So here we are doing decreasing, loss is decreasing. So with some momentum. So this momentum is taken care by learning rate. So when you vary the learning rate, initially I said you can keep constant, and you can vary. So we see when it is kept constant, you will be having zigzag. When you vary, you will be having some variations here. So that variation need to be smoother. So you need to vary in such a way that the learning rate, the particular path will be smoother and it will be reduced. So like this, we have optimizers used. We have Adagrad, Ada delta, RMS prop. So like this, we have several optimizers so that we can work on updating this things. So let me give you one more example so that you can easily remember this, because when you have a mountain, let's just assume that we have a mountain and this is a land space. You need to climb to the top. Usually wherever you go and wherever you see, when you are climbing the hill, you will not have a straight path. You will not have a straight path. When you have a straight path, it is very difficult to climb. So it is like something like a gravitational force. The gravitational force is more with respect to the perpendicular to the land. So when it is parallel, the gravitation force is somewhat less. So what we'll do is we'll reduce that and make sure that we don't have a perpendicular path and reduce our difficulty. So for that, what someone has done is, when you have a zigzag path like this, when you have a zigzag path like this and reaching this, you will be reaching without any difficulty. Without difficulty, you will reach the tip of the mountain. And see to that, the path that you have chosen is smoother and such a way that it is taking less time. So it should be smoother. That means easier. The path that you have chosen when doing a trucking, it will be smoother. So I'm just relating this into my problem statement now. So you can also have like this path with the sharp or curves. So when you have these kind of path like this, so the curve is also a sharper and it is quite difficult when you have these kind of curves. So you need to have a smoother path. So that's the reason I've told you, when you have to reach the global minima, when you want to reach the global minima, you need not to have the path like this, zigzag path. So it is a rate of change and it is taking some time to get change, and it is decreasing. But to reach like this, it will be taking so much of time. So when you have a graph like this, so it is reaching like this. So you see, one variation, two variation, three variation, and reached. Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 steps are taken to reach the global minima. When you have a smooth, you will be reaching with 4 steps. So this is efficient, right? So we make the path smoother. So for that, we need some momentum to make sure that someone there to push at constant speed, and so that it will be smoother to reach the destination, that is global minimum. So this is a basic idea that we have with respect to neural network. So same way, the network or the model what we are designing need to learn and get trained to predict the output. So you'll be having a data, and the last column we'll take it as a output column, and we'll say yes, no, yes, no, yes, no, and you'll be having observations. And when it is predicting no, and it is predicting no, it is predicting yes, it is predict no, it is yes, and this is no. So what is the prediction? Here it is 98%. Only 1% somewhere went wrong out of 10 predictions. 2, 1 are wrong. So we'll be getting 98% accuracy. The other are correct. So like this, you'll predict the levels of accuracy and then check whether your model is understood with the values or not. So if it is getting trained in future, if you have any inputs with some other variations, it will get understand and it will predict your answers. Okay, so shall we move on to the coding part? So we'll move on to the coding part. So here I'm considering, okay, let me connect this because a long time I have connected. It is getting connected. So I'll just change the runtime. So it is getting initialized. I'm using Google Colab. So now it got initialized. Okay, now it is connected. So since I'm reading the data and working with those values, I'll be having NumPy and pandas. And for model, you need to have Keras. So we are using Keras framework for our neural network. So what Keras is going to do is it creates a model and helps us to create a network like this. So this is in sequence. The input should be connected to a hidden layer should be connected to output layer. So there is a sequence. So we are using sequential model. So this is what sequential model. We also have one more model, that is functional model. So our functional model. So we have sequential model and functional model. And we have layers and it is densely connected. That means we have a layers. Here you can see this one should be connected equally. So there are 6 connections. There should be 6 connections when you have 3 inputs, 2 neurons. So you'll be having 2 outputs, or you can have only 1 output, like this you can have. So you'll be having a dense layer that has been created. And after that, I'll be reading the data. So my data is credit card CSV file and it has been read. And you'll be having some columns, 30 columns. So where I'll be mentioning those and I'll be listing all the 5 data set, 5 observations. And after that, I just split the data and make sure that some column is treated to be as output and all others as considered to be as input. So when I consider the last column, that is class column in the data, the particular column is completely considered to be as output. So I want you to break that and mention the axis 1 means it's a column. Axis 1 means column, axis 0 means row. So I need a particular column, completely particular column, to be dropped from the data set. So after dropping data set, let's say example, you have some other features connected. So this is also connected. This is Y output and this is separated. So you'll be having this column Y and all others are the inputs. So we are dropping Y from the original data set and we are making it as separate. So this is what we are doing because we need to check with the actual and prediction. From this input, again, we'll divide train and test data. So 80% of the train data has been set. So here I'm taking 20.25. That means this is 25 and this will be 75. So I'm dividing the data set as 75 and 25. 75 train data and test data as 25, the size of the test data. So now what I'm doing is I'm just creating the network with the help of sequential format. So this sequential will create a dense layer with the input dimensions as 30. So how many columns I have? I have 30 columns. I've created the 30. And I'm using activation function as ReLU activation function. So ReLU has 0, x. This is a formula for ReLU activation function. And I'll be having a hidden layer where you'll be having again 250 activation neurons and one activation function. So every activation neuron will have a activation function and that is ReLU. So we can use respective activation functions. We have so many like leaky ReLU, eReLU, ReLU. ReLU is rectifier logical unit, linear unit. I'm so sorry, linear unit. So it has been used, which is very efficient when compared to all other activation function. So we were using sigmoid function as an activation function earlier. So we got vanishing gradient problem. So when we use sigmoid function, we used to get vanishing gradient problem. Hence to overcome that, we have several activation functions and one among them efficient is ReLU activation function. So we'll use that ReLU activation function to create our network and use in the hidden layer as well as input layer. Now here, after that, we'll have a output layer. So here output layer is only one. So if I give this as only one, saying that you are predicting whatever the input that has been given and saying that it is fraudulent. You are predicting fraudulent and the actual is also fraudulent. Then there is no loss. If you are predicting that it is legal transaction and if you say fraudulent, then there is a mismatch. This is a prediction and this is actual one. So actual and prediction should be same. So legal transaction and fraudulent transaction should match. So one neuron is enough for the output. You need not to have twice, two. One is fraudulent for one is legal. So it is assumed that whenever I predict a legal, it is going and check for the actual and so if it is matches, then it's fine. So you need not to have the two output neuron. So we are considering only one. So you'll be having a optimizer, Adam optimizer, and you'll be having a loss function. So we have mean error. So mean absolute error, mean square error. So like this, you have several loss functions calculations. So here also we are using mean squared error. Okay, the matrix is we are using we'll have accuracy matrix also there. We have MSC matrix. Like this, we have several matrices that will be calculated with respect to the network that we have. And after that, I'm setting my epochs, how many times it needs to learn, needs to traverse. That is whole code. So whole observation need to traverse through the network model. So that is decided by number of epochs. So hence I have 20 epochs I've run. So initially there was a huge loss function, and there will be a error also. So because of this error only, there will be a loss. So when you are doing first epoch, that means all observation passing through the network, observation, this is observation passing through the network will have a some loss function. It is not going to predict something. So it will go back and it will get update with the weights, and then again it will come back for the next epoch. So for the next epoch, you will be having again with all the observations. So you can see that the loss function or the error function has been reduced. So it has been reduced drastically, and it becomes after some epochs, it will be 0. So that means when you are running your epochs, it will be learning. Okay, you can see that once it reaches some place, you can see that once it reaches some place, the learning mechanism, it is stopped. So there is no variation in the loss and error. Let's say example, I've trained child and I've asked child for n number of times with the dog, and the child is predicting what is dog and is able to identify the dog. Then I'll stop there because child already learned and identifying the animal. So even there is a change in the epochs or increase in the number of epochs, you'll be getting the same loss function and error function. So for the data, given data, I need to predict the relation. So correlation coefficient that I need to predict with respect to test data as well as with respect to train data. So initially we have done splitting with the train data and test data. So this is 75% of the data observations what we have. Randomly it will pick and it will split 75%, and 25% it will get split. And here we are just also checking the model or the network that consists how many layers. So one is hidden layer, one is neuron layer, and then another one is output layer. So we'll be getting 3 layers. So we are also doing for testing. So you'll be having 100% accuracy. So not 100%. There are few also something like you can just expect 98 or 95, 98% your data is accurate with the help of test data. So train data, test data will be almost similar with this accuracy level. So our model, network model, what we have created has learned in understanding the data set that we have given. And it is telling that whatever you have yes, no, at the class, it is not yes, no. Here it is legal and fraudulent. Legal and fraudulent. So whatever you have given this, it is going to understand and divide that as a legal and fraudulent. So this data is understood by this network. So whenever there is a new input to this model, Now it is going to predict saying yes or no, so that you can just analyze whether the transaction that has been done by the person is fraud or not. Fraud or not. Two things that we can identify. So hence, neural network is helping us to predict the values faster than machine learning method, and also accuracy level is also increased. So some of the classification model, also we use SPM, logistic regression. So this also gives you, with respect to 98%, 96%, 85% respectively. We also have decision. We have seen decision tree, logistic regression, SPM. We haven't seen SPM, but I've tried that. So logistic regression is pretty good, and it is going to provide you with respect to 96 to 98% of accuracy level. And even network model is also acting as a classifier, which is giving you either fraudulent or not fraudulent. So it is going to understood by the model, by the data. So this is all about with respect to neural network, where you need to understand how do you define the neural network and what are the optimizers that we use, what is the loss function that we use, how do you define in sequential model. So all this you need to understand. So this is with respect to neural network. So if you have any doubts, you can just clarify. Okay, there is a question saying that, yeah, binary classification will use sigmoid, and we can also use some other like tanh. So we'll be using. And when you have a binary classification, we'll use sigmoid function, but we'll be using sigmoid function, activation function in the output region, output neuron. But in hidden layer, we'll use either ReLU function, leaky ReLU, pre-ReLU, tanh. And whenever, one thing I just forgot to tell you, that I've told you that few of the classifications will be there. So that is with respect to binary and multi. So when I say binary and multi classification, in binary, in the hidden layer, we'll be using tanh or ReLU or leaky ReLU. We have these activation functions, but in the output, we'll use sigmoid. Okay, this is a procedure. So when you have multi-classification in the hidden layer, we'll use best activation function, that is ReLU, and the output we'll use softmax. So this is one important thing that you need to be aware. So for this, okay, this is for classification, and one of you are asking for regression. Okay, when you use regression problem, this is for classification. When you use a regression for problem, so hidden layer you can as usual use ReLU. In the output we can't use softmax because it is classification, it is regression. Regression you can use linear activation function. So there is linear activation function, you can use that in the output layer. So it's a separate loss function that will be calculated. So when you have output as continuous, you'll be obviously go with the when the output is continuous. When the output is continuous, you'll go with regression. When the having a categorical data or discrete, so then you'll go with the binary classification or multi-classification. If it is binary classification, you'll go with ReLU. Commonly, you can use hidden layer with all ReLU functions, and in the output, you can just make use of binary. If it is binary classification, you can make use of sigmoid. If it is multi, then you can make use of softmax. If it is regression, you can make use of linear activation function. So hope it makes sense and you learned some concepts about neural network, and you understood how do we create a neural network and how epochs is performed. So you just try with once by any neural network concepts and then try to understand the rest of the concepts. So thank you all for your time. We'll wind up here. If you don't have any questions to discuss, we can wind up here. And please do subscribe for 360DigiTMG YouTube channel, because 360DigiTMG is coming up with wonderful program that they are dealing with more analytical part, that is data analytics on various domains. It is very useful that irrespective of the domain, whether you are in agricultural, finance, HR, marketing, manufacturing, whatever human resource HR, that is whatever department that you are, you need some data to be analyzed. So hence we are concentrating and we are aiming to reach all the domains and then give you all the insights on that, so that how these regression model, classification model, neural network model will help us in analyzing these data and get you the output. So next week also we have some of the concepts that is discussing, and also we are coming up with make you understand with the basic programming language like Python, for that is required for data science, machine learning. So that is also there, and you also know about neural network concept, which will be guided by Mr. Barani, our CEO, having a 15 years of experience. We can make use of his knowledge. So he'll be handling a session in such a way that it is more interesting, as well as it will be hands-on, and he'll be sharing all his experience, what he has done with respect to industrial projects, real-time projects. So he'll be giving all his experiences in that videos. So please do subscribe for that and get a notification and try to attend that sessions and make use of it. So thank you so much, guys. So we'll meet in the next sessions. Hope you all have a nice time. Thank you all. Bye. Take care.